Hello guys, today we will be looking at the problem find number. So let's see what it says. Here is the problem statement and it says that given an integer n, you need to find the nth smallest number which only contains odd digits and the odd digits are given here. So there's a list given of digits which is 1, 3, 5, 7, 9 and we need to form numbers out of all these numbers and from those numbers our task is to return the nth smallest number. Let me explain. So we have this particular list, right? And from this list we can form number as 1, 3, 5, 7, 9, and then I have 1 1, 1 3, 1 5, 1 7, 1 9, and so on. Here you can see that I have written the number from the smallest to the largest. There's a reason because I want to find the nth smallest number, right? So let's say we have to find the 10th smallest number, 10th. So I can just count the values from this 1 2 3 4 5 6 7 8 9 and 10. So this 19 is going to be the answer in that case. And talking about this particular example, so here we need to find the third smallest number. So the third smallest number is going to be 1 2 3, which is this 5. So this 5 is the answer. Now I hope you have understood the problem well. So let's talk about the solution. Now I have written the same list from which we can pick the values, and I'm going to start with building all the one digit numbers. Then we will talk about the two digit numbers. So for the one digit number, the task is simple. We can pick any digit, but here I have picked the digit from smallest to the largest. You can see here, right? These are the one digit numbers that can be formed. What about the two digit numbers? For the two digit numbers, let's say we have the places for two digit, and for the first digit we have five options. We can either have 1 at this place, or 3 or 5 or 7 or 9. So any number can be at this place. So there are five ways. And what about the second digit? For the second digit again we have five ways. You can see here because the repetition of numbers is allowed, right? So we have five ways again, and the total numbers that are going to be 25. So there are 25 ways to form a two digit number, and you can see that I have written all the 25 numbers here. First, we have the numbers starting with 1. These are the numbers. Then we have numbers starting with 3. Then we have the numbers starting with 5. We have the numbers starting with 7 and then 4, 9. Fine. Now, what about 3 digit numbers? For the 3 digit numbers, you can see that this one has option to get attached to any of these digits. Like you can see that I have 1 1 and then 1 is basically attached behind this, right? And again we have 3, we have 5, we have 117 or 119, right? There are five ways just for this one. Again we have four more elements, right? We have five elements and for each element we have five ways. So this way, just for this one we have 25 ways, right? You can see that 5 into 5, just for this one we have 25 ways. And talking about all the numbers, these are the numbers which are starting with 1, right? 25 numbers. What about the numbers which are starting with 3? Again I have 25 ways. So this way for all the numbers I will have 25 into 25 ways. This means that the total three digit numbers that can be formed is going to be 125. Now we can get the same thing from this particular formula. Let's say we have to form a three digit number. So for the first digit we have five options, for the second digit we have again five options, and for the third digit we have again five options. This way I have total 125 options, right? Okay, now I hope you have got this thing. Now we are going to talk about a very important observation from this. See what is observation. You can see that for the last digit number, like for the two digit numbers and even for the three digit numbers, the last digit always changes at the interval of 1. We have 1, then just after this number we have 3, then just after this number we have 5, just after this number we have 7, just after this number we have 9, and again the digits are repeating in the same order, right? This means that the changing interval for the last digit is going to be 1. Okay, so for this, the last digit, the changing interval is going to be 1. And for the second last digit, you can see that the changing interval is 5 here. How? I have 1 repeated 5 times. Here I have 3 repeated 5 times. Here I have 5 repeated 5 times. Here I have 7 repeated 5 times. Similarly, for this 9. Now, what about 3 digit numbers? For the 3 digit numbers, you can see that this one gets repeated 25 times. Why? Because for this 1 1 we have 5 options. For this 1 3 again we have 5 options. For this 1 5 again we have 5 options. So this means that just for this one we have 25 numbers which are starting with this one. Okay, we can write this observation. Let me write this observation. I am going to remove this, and now I am going to write this observation here. Let's say I have a 4-digit number. For the first digit, the changing interval is going to be 1. For the second digit, the changing interval is going to be 5. You can even notice from this thing. And for the third digit, the changing interval is going to be 25. And for the fourth digit, the changing interval is going to be 125. And this is going to keep increasing for all the numbers, right? Fine. So we have made this observation. Now let's talk about an example. So I have written the same observation here, and now I'm going to take an example. Let's say I have to find the number at 123rd place. So I need to write 123 here. Now for the first digit, we know that the digit repeat after one after the other. Like the digit changes one after the other. The interval is 1, so I have 1 3 5 7 9. Again I have 1 3 5 7 9. So let me write the list here. The list of numbers is 1 3 5 7 9, and these numbers keep repeating themselves, right? So first I have 1 3 5 7 9, then again 1 3 5 7 9. For the first iteration I have counted 5 elements. For the second iteration I have counted how many elements I have counted. I have counted 10 elements, right? For the third iteration I have again counted 15 elements. So I'll keep counting till 123rd element. Why? Because I want to get the last digit at the 123rd element. Make sense? Okay. Now this way if I keep counting, then on the 24th iteration I would have counted 120 different numbers. Fine. Now I can't count 5 more numbers, right? So I can only count 3 numbers now, because I have already counted 120 numbers, and now I just need to count 3 more numbers. So I'll count this one, then I will count this 3, then I will count this 5. This means that this 5 is surely going to have the last place for the 123rd number. I hope you have understood till now. Now let's talk about this second last number. So in order to explain this, I'm going to write all the numbers. You can see that we have the numbers, like 2-digit numbers that we have are 1 1, 1 3, then 1 5, then 1 7, then 1 9. Again we have two, okay, so 3 1, 3 3, 3 5, 3 7, 3 9, and so on, right? Okay, now notice one thing from this. While counting the numbers for the first digit number, you can see that we have counted 24 intervals of 5. Can I say this? So we have counted 5 numbers, then again I have counted 5 numbers, again I have counted 5 numbers, and I have done this thing 1 2 3 till 24, till 24. This means that I have counted 24 intervals of 5, and this is what we need here, because I know value changes after the interval of 5, right? So I just want to know how many intervals I have counted, because if I can find the interval, the value, like the interval that we need to know, after that we can simply find the value. Let me explain how. So for this we have 24 intervals, and for this we have 123 value. Why 123? Because the interval is 1 for this and interval is 5 for this. Fine. Now we have counted 24 intervals, and I know for after each interval the value changes. After each interval of 5, the value changes. Like if initially the value is 1, then it will become 3, then 5, then 7, then 9, then it will repeat itself. So again I can do the same thing. I can keep counting the values till 24. So I'll keep 1 2 3 4 5. So I will have 5 10 15, and in the fourth iteration I will have 20 elements, right? And now I just need to count 4 more elements. So I can write this. I can write 24 as 4 into 5 plus 4, right? So this is the remainder that we will be left with while counting all the complete intervals. So once we have counted all the complete intervals, then I will have 4 elements left. So I will count 1 3 5 7. Now I can surely say that for this second digit we are going to have 7 at this place. I hope this makes sense to you. Fine. Similarly, for this 20 for this third digit, you can see that if I divide this interval, because the interval is 25 for this, so if I divide this 123 by 25, so I will have answer 4. And this means that while counting these numbers, I have counted 4 intervals of 25, and this is what I want here. So I can simply do this n, if this is n, let's say this is n and this is n by 5, so I can do n by 25 here, right? Okay, but instead of doing this n by 25, we can do one more interesting thing. We have already done n by 5 here, right? So we can do n by 5. Okay, let me remove this. We can do n by 5 and we can divide this value by 5 again. Let me explain how we are going to do this. So our code, our implementation will look something like, I need a while loop for this, right? So I need a while loop, and this while loop is going to run while n is not equal to 0. And inside this, I'm dividing the value of n by 5 each time, isn't it? N by 5, then again if I do n by 5, then I will have n by 25, then again I will have n by 25, 25, again I will do n by like 1 by 5, so it will give me n by 125. This is what I'm doing. Okay, and inside this, how I'm finding the value? I'm finding the remainder each time. For this the remainder was 3, and for this the remainder was 4, right? So we are going to find the remainder. In order to find the remainder, we are doing remainder going to be equal to n mod 5. Fine. And once we have found the remainder, so we just need to check the value. We just need to check the value at that place. What it means? It means that, let's say our remainder is 4. Let's say for this our remainder was 3, right? For this our remainder was 3, so we are just looking at the third value. And for this the remainder was 4, so we are looking at the fourth value. Fine. So what we can do is, we can just look for the value. So the value is going to be, value is like value at remainder, right? Fine. Now I need to store this in my answer. So let's say the value is 5, so I need to store this 5 at the first place, and I need to store this 7 at the third place, second place, and similarly let's say I have to store 7 at this third place. How to store it? So I know, for a number with base 10, how the number is represented. This is basically 0, and this is the first digit number, this is 10 and this is the second digit number, this is 100 and this is the third digit number, and this is 1000, this is the fourth digit number, right? So we can create this number. Let's say I want to do the number at third place, so I just need to multiply by 100. So we can keep track of the number that we have. So in order to do this, we are going to keep track of power of 10. I will call it P. So I just need to keep track of this power. When I come to this, then I will have power at 0. When I come to this, then the power will be 10, and when I come to this, then the power will be 100. So let's say the number that we already have is 75, and I need to add 7 here. So how I will do? I will basically multiply this power with this 7. So this will become 7 into power, and then I will add this number, which is 75. And if I do so, then I will have 700 plus 75. This is going to give me 775, and our task is done, right? So I'm going to write this here. Let me remove this. I'm going to write the same thing here. My answer, let's say my answer is here. So answer is initially 0, and answer is going to be answer plus, and this value multiply with power. And initially I have the power as 1 for the initial. Okay, so I have written a wrong thing here. The power actually should be 1 here, right? The power should be 1 here. So inside this loop, I will keep incrementing the power by 10. So power will be equal to power multiply by 10. Now this is the answer that we need to write. And at last we can simply return answer. Okay, now this answer has one problem. And I need to discuss because this is really important. Let me explain. So here I have written the same code, and I have written the values here as well, first 10 values, right? For the first value, when I need to find the value, when I run this code, then I will end up with 0 into 5 plus 1 for the first number. So now n has become 0, so I will stop at this point, and the answer at 1 will be my answer. So you can see that the answer is 1. Okay, one more thing is, why I have written this 9 in the front? Why I have written this 9 in the front? This is how we need to make the list. Let me explain why. So for the first number, you can see that let me remove all this stuff. This is really confusing. Let me remove all this stuff, and I have the list as 13579, right? So for the first number, I will have the remainder as 1. This is what I have. And for the second number, I will have the remainder as 2. And for the third number, I will have remainder as 3. For the fourth number, I will have the remainder as 4. And for the fifth number, I will have the remainder as 0. And whenever you see the fifth number, then you can find that the value is 9 at that place, even 1 3 5 7 9, so value should be 9 for the remainder 0, right? And as we are looking for the remainder, you can see that for this we are looking at the remainder in the list, right? So when the remainder is 0, then it should access this 9, so that's why the 9 is in the front of the list. This is the actual list that we need to process. Now let me talk about the main point. So the main point was, you can write something like this, and if you try to run for 2, then you will find that the answer will be something like this. So if you look for the value 2, then you will find that the answer is 3, right? Index 2. Similarly for this as well, and similarly for this 4 as well. What about this 9? For this 5, for this 5 you can write that 1 into 5 plus 0, right? You can write. Now this is the remainder, so it will look for the value at 0th index, and this is going to give me 9. Fine, this is correct till now. But what about this 1? Since the value is not 0 till now, then it is again going to go to the same iteration, and it will check, hey, the n is not 0 till now, n is 1. So if the n is 1, then it will come to this point and it will give me 1 in the front as well. But this is not the correct answer, right? In order to handle this, we need to make this 5 as like, we need to make this 0, right? So once we have 0, then we can simply return this 9. And similarly for this as well, if you find for this, then you will notice that all numbers here will have 1 into 5, 1 into 5, 1 into 5, and 1 into 5, and these are going to have remainder as 1, 2, 3, and 4, right? The value will be like this. But for this, the value will be something ambiguous. It will be 2 cross 5 plus 0. This 0 is correct, but this 2 is not correct. I don't need to run this iteration for 2. Instead, I need to make this 1 similar to this series, right? So in order to make this 1, I will check, before dividing the value, I will check one thing. So let me remove this here, and let me write this here. So I will check one thing. If my n mod 5 is double equal to 0, in that case you can see that n by 5 is going to give me 1, right? And even n by 5 is going to give me 2 here. But I want to reduce this value by 1, so I will do n minus equal to 1, and this is again going to give me 1 here and 0 here. So this is the whole code that we need to write in order to get our problem accepted. I hope you have understood the problem and the intuition and the approach as well. So let me show you the code. This is the code that we need to write. The code is very short and simple, you can see here, but I hope you are clear with the idea. This is the C++ code that we have, and this is the Python code. Now this is all about this video. I hope you guys have liked the video, and if you are new here, then you can subscribe the channel. Thank you.